Alright guys, so hopefully you guys did fairly well on your quiz. Okay. Um, so today we're going to start into logs. So far we've been talking about exponential functions. Today we're going to start talking about logarithm functions. And just like we did with exponential or every other function family that we've done, alright, we're going to start off by graphing. The key thing to understand is that the exponential function and the logarithm function are inverses of each other. Okay? So, for example, if you look at the tables here, we can see that y equals 2 to the x, which we know is a exponential function, gives you this set of values. If I invert it and do x equals 2 to the y, all of the tables change. All the x's flip with the y's. All right. This is what we would call a logarithm function. Now, what you're going to learn is to be able to solve for y. Well, if you take x equals 2 to the y, we're going to take the log of both sides. So I would get log of x equals log of 2 to the y. Then we can pull the y out front. So log of x equals y times the log of 2. And the log of 2, well, that's just a constant. That's just a number. So I divide both sides, and I get y equals the log of x over the log of 2. Okay? But we're not going to get into the solving today. This is just a showing of how it turns into that. Okay? And those are logarithms. But to graph it, we pretty much do the same process as everything else. Now, yes, each function family has its own little uniquenesses, its own little quirks. All right? And you do have to know how each function family uses those. However, they all kind of move and shift and work the same way. For logarithms, our basic parent function is f of x equals log base b of x. Okay? So when there's a number down there, we would say log base 2 of x, or log base 6 of x, or log base 9 of x. If there's not a number down there, for example, if they just write this, f of x equals log s, or sorry, f of x equals log x, it's understood that my base is 10. Okay? It's understood that the base is 10 if there's no number there. Otherwise, they're going to have to put a number there. So, if we look at all the properties here, all right, remember, these are inverses of exponential. Well, in an exponential, all the domains were all real numbers, and all the ranges were all positive numbers. Well, now they've switched. In a logarithm, the range is now all real numbers, and the domain is going to be all positives. Basically, it's going to kind of be just the same as an exponential, except instead of k being your horizontal asymptote moving up and down and determining what the range was, now your asymptote is going to be vertical, and it's going to be your h. And it's going to shift left or right to determine what the domain is. Notice the asymptote is no longer the x-axis, it's the f of x-axis, or the y-axis. And your intercept, instead of being 0, 1, your intercept is now 1, 0. Okay? Now, to graph a basic log function, you want 3 points. You want your intercept point, which is 1, 0. You want the point b1 and 1 over b negative 1. You want the point 1, 0, which is your intercept, b1, and 1 over b negative 1. You have to remember those three. So b1, 1, 0, 1 over b negative 1. Will it always be those? No. Because we're eventually going to add in a, h, and k, just like every other function family. But for the time being, we want those three. Now notice the graphs are a little bit different. And again, this is because this is the graph if b is greater than 1. And then this is the graph if b is a fraction between 0 and 1. Okay? Just like with exponentials. It swooped up. If it was b greater than 1, it was an exponential growth. And it swooped down, it was a decay if b was a fraction between 0 and 1. Now, I'm going to quickly go through this lesson. Remember, this is on YouTube, you're watching a video. If you need to stop, rewind, okay? If you want to pause it to write down a question to ask the next block, whatever you need to do that. So, the steps to graphing a log are pretty simple. You've got 4 basic steps. First one is identifying your base. Again, your base is whatever little number is the subscript of the log. All right? For example, here, if I have the function f of x equals log base 5 of x, my base is going to be 5. B equals 5. So, now I want those 3 points. My intersection point is 1, 0. And then remember, I wanted b1 and 1 over b negative 1. So, since b is 5, I have the coordinate 5, 1, and the coordinate 1/5, negative 1. And we can see on the graph, they plotted 1, 0 here, 5, 1 here, and 1 over 5, negative 1 here. My h value is 0, so that means I have the horizontal asymptote here on the f of x line. And then I simply graph the function. It's as simple as that. And again, if you want your domain is going to be everything from 0 to positive infinity, because it's on the right side of the asymptote. And my range is going to be negative infinity to infinity. Okay? So, again, this is one where my b is larger than 1. If my b is between 0 and 1, like this one, where I have log base 1/3 of x, we identify that my b is 1/3. So when I go to do my points, I do the coordinate 1, 0. When I do b1, well, that's just 1/3, 1. And then I want 1 over b negative 1. Well, 1 over 1/3 multiplied by its reciprocal gives me 3. So I get 3 negative 1. Alright? And again, I can see they plotted 1, 0, 1/3, 1, 3 negative 1. And notice that the fraction does it itself, so you don't have to worry about, am I graphing it the right way? Okay? If you do it correctly, it'll show you now, instead of swooping from negative infinity up to positive infinity, it's now coming from positive infinity down the asymptote on the y-axis and continuing on to negative infinity. And again, domain is still all numbers bigger than 0. Range is still all real numbers. Okay? So, if you want, pause it now and try these 2 on your own. So, if I have f of x equals log base 2 of x, that means my base is 2. My h is 0, so that means I'm going to have a horizontal asymptote at 0. Sorry, vertical asymptote at 0. And since b is 2, I have my intersection point or intercept point of 1, 0, and then I have my b1 and my 1 over b negative 1. So I plot the point. Now these are kind of small. asymptote. So I have my point 1, 0. I have my point 2, 1. And my point 1/2, negative 1. And there's my graph. Alright? Same rule applies again if b is between 0 and 1. Here my base is 1/8. This is log base 1/8 of x. So, still have my vertical asymptote at 0. So I need to find my 3 points. 1, 0 is my intercept. Again, b1, that gives me 1/8, 1. And 1 over b, negative 1. So 1 over 1/8 is 8, negative 1. So here's my 1, 0, my 1/8, 1, and my 8, negative 1. And there's my graph. Now, are they always going to be this simple? Obviously not. So let's add in our AH and K. Now, the key here is you want to find your AH and your K, but you have to find all the parts we've already found first before you do anything to them. So you're going to find what the original function would look like without AH and K. You're going to find those original 3 points. And then you're going to shift them left, right, up, down, squish, squish, stretch, whatever you're going to do to them after you've found those points. Okay? So, for example, let's see here. All right. As you can see, I quickly blew up my grid so it's easier to see. So say we want to graph this function right here. Now, they've already kind of done it for you, but we're going to do it out. So I have the function f of x equals 3 log base 10 of x plus 1. All right? The first thing you want to do is you want to identify your 3 points. So we got 1, 0. And then we've got b1, by b is 10, so I have 10, 1. And then 1 over b negative 1. So I have 1 over b negative 1. Okay? Always identify your 3 original points first. Now you go through the process. Find your AH and your K. Well, my A value is 3. My H value is 0. My K value is positive 1. Okay? Remember, if it was an H value, kind of like if you look at the second problem we're going to work on, that would be in parentheses with the x. Okay? Now, you're going to apply all of these in the order we list them, like we always list them, AH and K. So the first thing you want to do is apply your A. All right, A is 3. Remember, A is a stretch. It always multiplies to your vertical move or your vertical number, which would be my y. So I need to take 3 and I need to multiply it to each one of these y values. So if I multiply 3 to it, this now becomes 10, 3, 1, 0, 1 over 10, negative 3, doesn't it? I took my vertical stretch, my A value, I multiplied it to each one of my y values. Now, I have an H value of 0, so that doesn't affect anything. But I have a K value of 1. Well, K moves everything vertically up 1, doesn't it? So that means now I need to add 1 to each one of my y values. So that means now that these points are going to become the coordinates 10, 4, 1, 1, and 1, 10, negative 2. That's how you get the points for the graph. My vertical asymptote is still going to be where? At 0. So, I draw my vertical asymptote. This helps see it better. Okay? And then plot my 3 points. I have the point 1, 1, 1/10, -2. So I'm somewhere over here. And then 10, 4. And there's your graph. Again, you find those 3 points, then apply your A value, then apply your H and your K value. Okay? And again, if you need to stop and replay, stop and replay. So, same process is going to go for this guy. First thing I want to find is my B and find my original points. Well, if I have 1/2 log base 1/4 of x minus 3, my base is 1/4. So, I've got 1, 0, 1/4, 1, because it's B1, and then 1 over B, 4, -1. Now I find my A, H, and K. Well, A is 1/2, H is 3, K is 0. If my H is 3, that means I have a vertical asymptote at 3. So there's my vertical asymptote. So, I've got my original points. Now apply your A. That means take the 1/2 and multiply to every single y value. So that gives me 1/4, 1/2, 1, 0, because 0 times anything is 0, and 4, -1/2. Now apply your H and your K. Well, H is your X, you're going to add it to your X. Your K is your Y, you're going to add or subtract it to your Y. Well, K is 0, so nothing changes there, but H is 3. And yes, you should be able to know how to add these without a calculator. 3 plus 1/4 is just 3 1/4, 1/2. 1 plus 3 is 4, 0. And 4 plus 3 is 7, -1/2. So those are my 3 coordinates. So now I plot them. 4, 0. 3 1/4, 1/2. So I'm somewhere around here. And then 7, -1/2. Somewhere around here. And there's my log graph. Very, 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 very simple. And truthfully, I'll kind of tell you in this part, we're going to go back and cover it next week. This is how we should have done exponentials. I don't know where my brain was that day. Don't ask me. All right. But we'll go back and kind of fix that a little bit next week. But you should be able to go back and relate, because in exponentials, you did 1, 0, 1, and then you would do 1 to the left of it, 1 to the right of it. But do the same thing. So get those 3 points, then multiply everything by A, then add or subtract on your H and your K. So exponentials works the exact same way. Okay? So, if you want, push pause. You guys try these 2. So, my B is 3. Actually, I'm going to hit pause. So, when you restart this, everything's going to pop up on the screen. And I'll just talk through it. Alright, so I've graphed both of them. Notice again, for 5A, I identified that the base was 3. My A was 2, my H was 2, my K was 0. So I started off with the 1 over B, 1. Hold on. Alright, sorry about that. We had a technical difficulty. So I identified that B was 3, A was 2, H was 2, K was 0. So I started off with my B 1, 1, 0, 1 over B negative 1. So I got 3, 1, 1, 0, 1 third 1. Then I applied my a, so I multiplied a to each one of the y values. Got 3, 2, 1, 0, and 1/3 negative 2. Then I had to add 2 to my x's because h equaled 2. So I get 5, 2, 3, 0, 2 and 1/3 negative 2. I plotted each one of my points, one here, one here, one here, and I graphed my log. All right. On the other one, I notice I have a b of 1/2, an a of 1/4, an h of -1, and a k of -5. So I started off with my b1, 1, 0, 1 over b -1. So 1/2, 1, 1, 0, and 2 -1. I have an a of 1/4, so I have to multiply that in. So I get 1/2, 1/4, 1, 0, 2 -1/4. And then I have to subtract 1 from my x and subtract 5 from my y. So I get -1/2, -4 3/4, 0, -5, and 1, -5 and 1/4. So we notice these are clustered in here really close, and then I graph my log. Okay? Alright, so that's your lesson on graphing logs. On the back side of your notes is your homework. If you have time, you've got two options. You can either A, work on your homework, or B, work on your IXL assignments. Okay? I hope you have a good weekend, and I will see you guys next week.